Good morning, good afternoon, good evening, wherever you are, and welcome to the 54th session of the International IVF Initiative, or I3. I'm honored and excited to be co-hosting this session entitled Intuitive Embryology. For videos of our previous session, please go to ivfmeeting.com. Thank you for logging in. I encourage you to ask your questions using Q&A section of the conference service, and please not on the chat function. My name is Manar Hussain, and it's a great honor to be co-moderating this session with Dr. Rusty Poole. Rusty Poole is a scientific director of the Fertility Center of San Antonio, Texas for 34 years. Prior, he was an associate professor of cellular and structural biology at the University of Texas Medical School in San Antonio. He is board member of the Pacific Coast Fertility Society and serves on the editorial board of Fertility and Sterility and the Journal of Assisted Reproduction and Genetics. For more information about Dr. Rusty, you can visit I3 website. Hello, Dr. Rusty.
Thank you very much, Menard. It's a real pleasure to be here and welcome everyone from around the world. We're so happy to have you. And it's my pleasure to introduce my co-moderator, Manar Hussain. As you have heard, she's an elegant speaker. She is from Egypt. She has really done a fantastic job in the last several years. She's an expert in quality control and in a number of aspects of IVF. She received her training at Cairo University and then proceeded to receive her master's from the University of Messina in Italy. She's been in the field for about 9 years, but she has worked in the laboratory. She works in Gannon Fertility Center, which is one of the largest in the Middle East. So it's a real pleasure, Manar, to be joining you this afternoon. Before we get going, I want to also introduce, we have a very special panelist that's going to join us, and that's going to give us a real good international flair to this group. So it's a pleasure to introduce to you Dr. Julius Reinson. Julius received his undergraduate training at University of Iceland and then proceeded to earn a PhD from the Karolinska Institute in Stockholm. He has been a laboratory director. He has been an embryology consultant, and he's been in the field since 1991, so very well versed. He has also been in the accrediting boards of Denmark and Sweden, so he's exceedingly well versed in all aspects of ART. And Julius, thank you so much for joining us this afternoon.
Thank you, happy to join.
So we're just going to go ahead and start in. The whole idea today is to talk about intuitive embryology. That is those days when you're in the laboratory and things arise that may not fit into a protocol where you have to do some really quick thinking outside of the box. So what kind of approaches do people take to these scenarios? And we have 4 fantastic speakers for you this evening or afternoon, morning, wherever you may be. And it's a pleasure to introduce the first one. So what do you do when you walk into the laboratory and you have a very busy schedule and all of a sudden you have one of those sperm samples that you just didn't expect? There's next to no sperm in the sample, low count. What do you do about it? It doesn't fit into a protocol, so what do you do? The same thing for about doing a testicular biopsy samples, the difficult samples. What do you do about those? And we have one of the best people that I know of that can address this in terms of experience, and that's Graham Wright from RBA in Atlanta in the USA. Graham received his original training in 1985 in the UK. He actually has a degree in microbiology from Bristol University. He was trained by Jacques, but he came to the US in 1987 to join Jacques at RBA, and he's been there ever since. And Graham has about as much experience as anyone can have in ART. He has worked with laboratory directors such luminaries as Jacques and Michael Tucker and David Weininger and now Peter Nye. So it just strikes me before I introduce him, there's probably nobody better versed at retirement to write a book on the care and feeding of the lab director than Graham Wright. He's got that much experience. So no further ado, Graham, I'm going to turn it over to you.
Thank you, sir. I think it's just, what you get from being really, really old and just hanging around the longest in the lab. I'm going to talk today about prepping more difficult sperm preps. I've got a set of slides, if I can set that going here. Let's see. Most of our samples we prep with, these days, a Zymot chamber. So anything with a million per mil or motile or better will go on the Zymot. Anything other than that is low. we tend to run them over a gradient if it's an ejaculated sample, and then prepare it into a microdrop. This is what our microdrops kind of look like. So yeah, you come in, you've got a sperm prep like this one. You've got nothing motile. Actually, you don't even see any sperm. So we will put it over what I guess we call still a density gradient, although it's really not. It's just an 80% column of pure seption. Spin that, and then resuspend, wash twice, and then plate that out into a dish. Usually we use one of the sort of shallow-sided dishes we use for ICSI, so you can get your tools in more easily. So plate it out using a polished or flamed glass pipette so you don't get scrapes and scratches, and then just overlay with oil. And you'll end up with something kind of sort of like this, even though you don't see sperm at the beginning. With a bit of faith, you'll often find sperm where you know that there's, or you expect to be some, but maybe there's not so very many. And then from this, we pick up the sperm for ICSI using something as clean as this, probably just an ICSI needle. Although if it's something a bit with a bit more debris in it, we'll use a hatching needle, which I think they have a diameter of inside diameter of 30 microns, so a little bit bigger, but not as big as like a biopsy needle. Testicular sperm, you might be a little bit jealous looking at this picture. Our urologist does a really good job, Mike Witt, of giving us really nice, clean testicular samples. I've worked with people where the samples don't look anything alike as nice as this. And then we tease them out, dissect them with a couple of needles. I prefer 18 gauge, but people use smaller ones attached to syringes, and just tease them out. And you will eventually, you can see tubules, individual tubules. This particular case, we did not find any sperm. He has an AZT deletion, and these tubules look really kind of like devoid of any tissue within them. And we find in the final prep, the final microdrop prep of that particular patient, there are no sperm, but pretty nice and clean. This one, on the other hand, was an obstructive case, plenty of tissue, and these tubules just look so much nicer. They're sort of plump and dark, and you can really see cells within them. So we chop that one up and keep on chopping it up until we had a bunch of debris. Then we put all that into a conical flask, a conical tube, and vortex it, and you end up with just a really good mix. If you allow all the tissue to settle out, you end up with something like this. And then that supernatant of the top can be plated out into microdrops like this. And it's really easy to access with micro tools. And this is the final product of that particular sample. And you'll see there's a couple of sperm in here that are just kind of sort of twitching. And these can be picked up. I would use a hatching needle for these because there's a lot of debris in there that will clog up an ICSI needle. So pick them up from there and then move them into a PVP droplet in an ICSI dish. Just spend a bunch of time really collecting enough sperm to match the number of eggs that you've got. I mean, what I've spent probably 4 hours some days just sitting here picking up sperm from samples like this. But seems to do okay. And then picking and choosing the sperm, you know, it's a luxury, I guess, to have motility or twitching sperm. But we do quite well with non-motile sperm, especially if you kind of move them around a bit with the ICSI needle and kind of get an idea that the tail is flexible, and that maybe the sperm is alive. We've never really tried to do anything fancy like hypoosmotic swelling or adding chemicals to try and kind of invigorate the sperm, like pentoxyphylline or deoxyadenosine or caffeine, although I take plenty of caffeine. But none of that seems to have helped us when we've tried it.
Thank you, Dr. Graham, for the interesting presentation. Now we will turn to our next speaker, Dr. Perry Pear. You can see his bio through the website ivfmeeting.com. Briefly, Dr. Pear is the IVF Lab Director at Stanford University. He was the first non-MD president of the Pacific Coast Reproductive Society. Dr. Pear was the former president of the American Association of Bioanalysts in 2012 and 15 to 2016. In the 19th, Dr. Pear developed the embryo culture medium to the blastocyst stage. He was also the co-inventor of an embryo selection technology that was featured in Time magazine's Best of Everything at 8th place in the top of 10 medical breakthroughs in 2010. He has published over 200 peer-reviewed publications and book chapters. Welcome, Dr. Pear.
Thank you, Manar. It's nice to be part of this prestigious faculty and moderators, and I appreciate the opportunity to join you all to present on this topic of new equipment, new results, and what's important. I think many people who have been in this field for more than a few years will recognize this question, which is, if I can go to my next slide, is the IVF lab simply a conduit from the ovary to the uterus? Of course, we all know that IVF was really invented to bypass the fallopian tube in women who had absent or blocked tubes. But with the technology and the equipment we have today, it certainly has gone beyond the role of simply co-incubating or allowing the two gametes to meet. Of course, Louise Brown, who was born in 1978, was a result of not new equipment. This team had been working for about 10 years trying to do a successful in vitro fertilization and embryo transfer with a live birth, which culminated with Louise Brown. And it was very exciting to see this, obviously, which gave us all a profession, starting off with Jacques and others who are on here today. It was also rewarding to know that even with those old types of technology, that people could propagate even as a result of IVF and having their own families. But getting onto the topic, why new equipment? Why do people put new equipment into their laboratories? Why do we worry about this, or why do we do it? I've listed a few examples right here for us to see. Certainly compliance. There have been some experiences in our field that have resulted in changes in requirements or guidelines and compliance. Specifically, one example could be how we monitor and maintain our liquid nitrogen samples. Certainly programs have increased in size, they grow, they combine, and we need more space. And when you need more space, you typically have to fill that with more equipment. More staffing to handle more cases, requires more equipment for higher throughput. When we add new technology like time lapse or the upcoming RFID storing or tracking of cryo specimens like the Tomorrow system, we need to acquire those as we move down in time. Many programs outgrow their space and have to relocate. And when you relocate, like we did in my program about 4.5 years ago, it's a tremendous opportunity to upgrade your equipment. And then there's always the just because. There are many people that feel, my equipment's 10 years old, I need to replace it, or to literally keep up with the Joneses, and we once did in the old days. You change equipment. So what does new equipment generally bring for us? Besides allowing the throughput, it should give you some other benefit, like better performance, more stable incubation control, or features that you didn't have before that would provide better patient care, or better care for the embryologists, the people, the purveyors of these tissues. But they also provide new challenges. I don't think we should forget about that and lose sight of the fact that with new equipment, you need proper training. We need to make sure that competencies on these equipment are maintained and measurable. And anyone who's had a CAP or JACO inspection recently will know that this is a buzzword for the compliance officers. And then also maintaining the equipment. Buying new equipment is not a one-step process. The ongoing maintenance and ensuring the proper performance of the equipment is certainly key to ensuring that we have the best output from our our equipment. So what should we expect from our new equipment even further? You know, you're going to get 100% pregnancy rate or no more problems in the lab, no more headaches? Well, you know, absolutely not. If you believe that, I've got a bridge to sell you, but it's not really true. We have to recognize that, you know, nothing in life is 100% good. And when you introduce new things, you have to recognize that, you know, for every strength, there's a weakness, and we need to recognize the weaknesses so that we can be ready for them and address them should they appear. So what is the gold standard we're targeting when we buy new equipment or we move into a new lab? You know, what is it? You can talk about air quality, you can talk about room temperature, you can talk about light, you can talk about, you know, off-gassing, you can talk about materials. But really, in my opinion, there really isn't a gold standard. There's more like a minimum standard. And all of us, depending on the resources we have in our, you know, in our cities, in our countries, in our institutions, will essentially dictate the minimum standard that we're able to meet. So at the end of the day, buying a new piece of equipment doesn't change anything really, unless the IVF practices leverages the benefits from these new equipment. And that could be in, you know, higher throughput, doing more patients, making more money if it's a business, or having better incubation controls so that you can have better outcomes potentially. But at the end of the day, if you don't change anything, if you don't change how you work, you shouldn't really expect any major difference. As I mentioned, I moved into a state-of-the-art laboratory here a few years ago, four and a half years ago, and we did not witness, even with brand new everything, the best air quality we could buy, you know, the best equipment that money could buy at the time. We did not really have a palpable difference in success rate because our practice of the IVF whole practice didn't really change much. Certainly when we add PGT, freeze all, to the extent that we're doing now, results numerically have improved, but it's hard to compare our FETs, our frozen embryo transfer outcomes today from 3 or 4 years ago, because we're really comparing apples to oranges with respect to what the embryo had been subjected to, for example, a biopsy and aneuploidy screening. So again, don't expect different outcomes if you don't change anything. So how can you tell this is working? How do you know when your new equipment are doing what they're supposed to be doing? And there are many endpoints, and you can pick any, key indicators or key points that you want to use at the end of your assessment. Is it your FERT rate? Is it your blast rate? Is it your euploidy rate? Is it your birth rate? Is it the APGAR scores of your babies that are born after embryo transfer? And I think as we go down in time, we're going to be looking at things beyond birth that most of us don't focus on now in IVF. And I'm just sort of throwing that out there, given the technologies that are emerging in our field. But additionally, we can look at patient satisfaction. That's a key element of our performance, is how patients feel about what we do. And if our technology through apps or through communication technology can improve patient satisfaction, I think it's a worthy consideration and a sort of a sign that your technology is working. Of course, happy staff, makes a happy lab. And if the staff are happy, your equipment is doing what it's supposed to do, maybe taking some bricks out of the backpack, so to speak, it's going to be an advantage. And of course, SART in the United States, that sort of manages our image on the outside, or the outward facing image, is also one parameter we could use as a benchmark for our equipment is working through improved success rates. And I mentioned volume already. So I thought I would show you some examples of, this is my lab at Stanford, and I'd like to point out a few things. I'm not sure if you can see my pointer, but you'll notice we have a hard ceiling with vents, but more importantly, access points, multiple access points. Nothing works forever. And if you ever need to service the units and the ducts and the in-duct systems, it's important to have access. We have a monitoring inside the lab. We have additional outlets for gas, for expansion, planning on the future. We have materials that are stainless steel and enameled cabinets that do not give off-gassing. Or off-gas, many VOCs. We have ergonomic designs for our staff, new design chairs with armrests and things that allow staff to be comfortable. Video, HD video on all the equipment, so we can we can train, we can show patients, we can display our images in the various rooms that patients are treated in, embryo transfer rooms. We have a benchtop incubator, so we don't have to get up for transfers and biopsies, monitoring, remote monitoring of equipment. And also very exquisite control of the air quality. So these are some examples of leveraging new equipment in a new lab. Again, you can see these HD cameras on every microscope so that we can literally network the images. So that's about all I have to say for now. And I look forward to answering questions as they come up later on in the presentations. So thanks for your attention.
Barry, thank you very much. That was a fantastic presentation. We appreciate it. I just want to remind everyone what we're going to do is take all of the questions after the presentations have completed. And we hope that we will have a robust question and answer session. We're expecting that. So it's my pleasure to introduce the next speaker. This is Dr. Sangita Jindal. She's one of the better known lab directors in the US, and she has earned her PhD in physiology from the University of Toronto in Canada, but she's been an accredited HCLD lab director since 1997. She served on the faculty of the New Jersey Medical School at Rutgers, but she's been affiliated and on the faculty of Albert Einstein College of Medicine in New York City for the last 19 years, where she's an associate professor and the lab director in the Department of Obstetrics, Gynecology, and Women's Health. And just as a reminder, if you want to learn more about all of our speakers and their bios, it's on the I3 website. So we invite you to learn more about everyone. Appreciate that. Well, Sangita is going to talk to us today about how to prevent your lab from going viral, infectious disease, and the lab, some tips for handling. So thank you very much, Sangita.
Thank you, Rusty. I hope everyone can see my slides correctly. I'm sharing on 2 screens, so please let me know if there's an issue. So this is my talk, and I'd like to thank I3 for inviting me to discuss this important topic. It's my pleasure to be here. So I'm a lab director in New York, and in the context of this global pandemic, I thought it might be useful to review some tips for handling eggs, sperm, and embryos in the IVF lab from virus-positive patients. Now, I know the audience today is a global one, but since I'm based in the US, my reference point for treating virus-positive patients in the lab comes from the Americans with Disabilities Act. So this is a civil rights law from over 30 years ago, and it prohibits discrimination against individuals with disabilities from access to care. So it's predicated on being able to make reasonable accommodations for these individuals. So what I'll be talking about is how to make these reasonable accommodations in the IVF lab for individuals whose disabilities include living with a viral infection that can be contagious. Because let's face it, lab conditions are favorable for cells and therefore for viruses as well. And the goal is always to mitigate risk of exposure to both the staff and the patients. So in general, when we talk about virus-positive patients, these are the viruses we mean. So today I was not really planning to discuss the Zika virus or the Ebola virus or even the West Nile virus. I thought I would cover just 2 categories here, the bloodborne pathogens and aerosolized virus, which we all know very well for the last 14 months. So the bloodborne viruses include these 3, HIV, which can lead to AIDS. There is no vaccine, there is no cure, but there is a long-term treatment for mitigating the worst impact of AIDS and improving longevity. Hepatitis C, which can lead to liver failure, and there is a cure now. The virus can be present in follicular fluid, which may attach to granulosa cells, although the egg is protected by the zona pellucida, and the virus can also be present in semen. Hepatitis B, which also affects the liver, and there is a vaccine, which is widely available, and most, if not all, lab professionals I'm aware of have been vaccinated. Bloodborne viruses are transmitted through bodily fluids, which in the IVF lab include blood, follicular fluid, and semen. The main source of viral particles are in the somatic cells and in the white blood cells. And the main risk of exposure is through needle stick. Last but not least is an airborne virus known as SARS-CoV-2, which can lead to COVID-19, which is a respiratory-based illness, which can be fatal and which is highly contagious. But I'm happy now, very happy to say there are a number of vaccines available for COVID-19. So the philosophy I'm trying to impart to the audience today is risk reduction. It's risk reduction of exposure to staff and to patients. The serostatus of the couple becomes a guide to the appropriate treatment. And basically everything is predicated on enhanced universal precautions in the lab, which include the usual scrubs, hat, shoe covers, gloves, mask, face shield, goggles, avoiding sharps. These are all the usual enhanced universal precautions. And then I will add a few more in the context, good tissue practice for virus positive patients. So for good tissue practice for virus positive patients, I would recommend the following: that surfaces be wiped down with 6% hydrogen peroxide followed by distilled water, absolutely no mouth pipetting, cover tubes so that there's no aerosol-borne viruses escaping at the time of mixing or centrifugation, opening and closing capping, be very careful with that. Disposable contact material, and I feel like everybody's already using plastic disposable sterile plasticware. And no fan in the laminar flow head. So this is important because in a laminar flow hood, the flow comes over the contents of the hood onto the technician. So if you're working with virus positive patients, I would recommend that you turn off the fan while you have samples open in the hood. Several risk reduction strategies are here. Just a couple slides on that. I could recommend placing the patient at the end of the daily workflow to isolate the patient in time. And or you can culture the gametes and embryos in a separate incubator to isolate the patient in space. We recommend denuding oocytes completely and inseminating via ICSI rather than standard INSEM in order to reduce any amount of virus that may be in the seminal content that is then washed sperm, which is attached to the tail of the sperm. Cryopreserve embryos and keep them separately in a holding tank until they're shipped off-site to a long-term storage facility. And the last thing I'm going to talk about is something called the double tube method to process semen. And we have used this in all my labs, depending on what, for example, we had during the years of Zika, certainly during COVID. If there's a patient who's HIV or Hep C, if this husband, the partner is positive, we use the double tube method. So I don't know if you can see my pointer, but the top part of this slide is A, it's just a regular gradient followed by a swim up, and B is the double tube gradient. So in A, you basically set up your density gradient, and this is a two-phase gradient, and you place the seminal plasma on top. It is centrifuged down, and then you take out the modal sperm all the way through the contents of the tube, right through all the density gradients and through all the seminal plasma at the top in order to collect the wash pellet. In the double tube method, however, you're creating the gradient and placing the seminal plasma down the side of the tube outside of this central channel. So when you go in to collect the sample at the bottom, it is through the central channel, which has not had any gradient or seminal plasma touching the inside. So you're able to take out the pellet, move it to a new conical tube, and wash it twice before insemination. Finally, for SARS-CoV-2 patients, I feel like we all are doing this routinely, so I won't spend much time on this. We do screen our female patients. I mean, this is a virus that's airborne, so it's not as if the patient is in the lab and people are actually contagious in the laboratory, but the samples alone, they come from patients that have been screened and who are negative. The male patients can also be screened. We tend not to do that, but we do not ask the patient to come in, the partner to come in with the sample. It's only a drop off. So the partners who are providing semen samples do bring it in, but they are masked, they've filled out questionnaires, they've had temperatures taken, they're in the waiting room, they drop off the sample and they leave. They provide, of course, all the information in photo ID, we confirm who they are. Again, the double tube method for processing IUI, again, this or IVF, this is not standard. And yes, for FETs at the time of transfer, we're just trying to maintain social distancing, and we invite just the patient into the office at this time for her FET. And I believe that's all I had.
Thank you, Dr. Sangita, for your productive talk. And now that's our last talk today with Dr. Liesel Neltamat. You can see her bio through the website. But briefly, Dr. Liesel is the IVF lab director and an assistant professor at the University of Colorado Anschutz Medical Campus. She currently serves as the vice president of the Society of Reproductive Biologists and Technologists. She is on the membership committee of the College of Reproductive Biology and is on the Society of Assisted Reproductive Technology Practice Committee. Dr. Neltamat also co-founded and served as the first president of the Colorado Association of Reproductive Technologists for 4 years. Let's start with her.
Thank you so much, Minar. Thank you, I3. It's so nice to be back on the other side for a change. You know, usually I'm hosting. This is great to be on the side. So today I would like to talk about biopsy loading. By far, when people ask me what is the most technical challenging thing we do in the lab, I don't say ICSI, I don't say biopsy, I don't say egg vitrification. For me personally, getting that biopsy into the tube for shipping it to the genetics company is by far the most technically challenging because it's totally manual and there's so little room for error. So why is it so challenging? You have a tiny clump of cells, usually anything between 3 and 5 and 10 cells, a tiny pipette, the little bit of media, if it's not sealed properly, it can get sucked in by capillary force and you lose it. Then you have to align it perfectly with your tube. You get some fancy holders that's supposed to help you. I haven't tried them. I don't think you needed them, but it's difficult to go into the biopsy, into the tube without touching the side. And the moment your biopsy or your pipette touch the side, that biopsy is pretty much gone. And then, of course, every single genetics company require a different method of loading it. Some prefers wet loading, there's dry loading. Some say you have to rinse it, some say you have to wipe the oil off. So there's a different technique for every single company. However, the technique that I'm going to show you today can be used for any of these companies because it's simply how you get your pipette tip into the tube to expel your biopsy. This video that I'm going to show, I'm going to give you full disclosure, is a video that was made because one of my friends that recently started doing biopsies asked me, what can I do? This is so difficult. I lose the biopsies. And so I came up with this technique, how you can make sure you keep your biopsy tip where your biopsy is in the pipette level with the tube. So I took a video, my colleague David took a video of me and I sent it to her and she said it was so incredibly helpful, but it's definitely not for international professional stage. So I apologize for the quality, but Marianne, please play the video. Rules for setting up and loading. We use the 80 micrometer flexi peg tip. So we're already loaded on here. This is the tube rack. Already have the tubes labeled on the top, and I already have 2 microliters of the loading buffer in each tube. Some people like to do dry loading. With my technique, you can do either. We have our loading dish set up like this. We have a row for each biopsy with the drops that you're going to wash it through, and the number, and of course the patient name. This is the biopsy dish that I have the biopsies in them. Okay, so the first thing you want to do is you use the first drop that's on the left-hand side just to rinse your biopsy pipettes, which I don't have real biopsies in here. This is just to show you, just to rinse it, and then you fill the tip. you go and pick up your biopsy. First, you find your correct drop, of course. This was number 8, right? You want to expel some of the media over the biopsy, pick it up, and you go into your wash drop, find the right number, and you put it into the first drop, like that, okay? So, what you want to do, your tube, you want to have it ready so that you can load it. And you can put it here before you pick up the biopsy or after. But something that you want to do is make sure that your drop is in the bottom. And what I do is I give it a few taps like that to make sure that it's on the bottom. Then you want to finish your rinse with your biopsy. You pick it up from where it is, put it in the next drop. If you have oil on your pipette tip, you can go back into the previous drop and kind of rinse it like that to get rid of the oil. And you move it around 2 or 3 times, go to the next, go rinse your tip, go to the next, and then once it's in the final drop, you pick it up, and then you go and move your tube so it is in view. Zoom out a little bit so you can see the drop. Then I go to the opening so I can see the opening. I bring the needle or the pipette so I can see it, and then I just slide the tube over the pipette until it's in the drop and you expel your biopsy, okay? So I have my opening in focus, I bring my flexiped so I can see the opening and the tip, and I slide it over it until it reaches the drop and expel it. And then you can see your biopsy. Easy. Bye. That is embarrassing at best. Anyway, so for me, the big thing is you have to try to do anything to keep your focal plane for the tip of your pipette and the tube in one plane. And instead of trying to move your hand that is holding the biopsy, you hold that still and you just slide the tube over the tip. And for me, when I started doing that, that's when I stopped losing biopsies, knock on wood. So if anyone has any more questions about that, feel free to reach out. And again, thank you for this opportunity. Over to the team.
Thank you very much, Lisa. It was a fantastic presentation. So I think Julius is going to introduce a brief video that we're going to show you. So Julius, why don't you take it from here?
Yes, thank you. And first of all, a big hand to our speakers for excellent presentations. This was really fascinating and good material, and I'm sure it'll initiate some lively discussions afterwards. About a week ago, the speakers and the panelists recorded answers to certain key questions regarding lab methodology, and the answers were recorded and put together into a video that we're going to play, and it'll show, I think, in some cases how diverse our methods are, and in other cases how alike we work. But please take a few minutes to watch the video, and I'm sure that this will sponsor, or let's say give birth to interesting discussions afterwards.
I hatch at the time of biopsy, so that would be day 5 or day 6 of culture.
In my experience, there's no real advantage in doing the hatching early on day 2 or 3 or 4.
Well, I definitely believe in hatching before biopsy.
There's really no point. It's quite just as good to do the hatching at the time of biopsy.
I do have some labs that hatch on day 3 and wait for the trophectoderm cells to extrude, and then they biopsy on day 5. But I would personally recommend hatching at the time of biopsy.
To make the biopsy easier, I hatch on day 1. I have some data to share coming soon, so stay tuned. Instead of doing it on day 3, because I have the embryos out for routine FERT check, and I do it at that time.
Absolutely. We like to hatch on day 4 so we can see where the ICM is going to be, and it will push out nicely the trophectoderm, so it's very easy to cut it off.
We do not hatch before we biopsy. I think we've tried it, and we found that every now and then the ICM will pop out through the through the hatching hole, and it just becomes more of a challenge than you need. And we found no real issues with biopsying or hatching at the time of biopsy.
We actually didn't. I mean, you can see publications going both ways, and I don't really see any theoretical argument why it would be better to hatch in advance. What do you think?
If we do happen to hatch on day 5, that's fine too. We're not picky about that, but we usually do it on day 4, sometimes day 3. It also depends on our lab schedule. We're not going to come into the lab just to do a hatch. So it kind of depends, but usually it's on day 4.
We prefer to do our testicular biopsies on the day. I think frozen samples don't seem to work as well. Doing it the day before is fine too, and gives you maybe a bit more time to pick up sperm if you can't find them easily.
I prefer fresh sperm. I prefer fresh everything.
For men who require testicular biopsy, if it's non-obstructive azoospermia, so we do not expect good samples, then I would like to do it fresh if possible, or even the day before without freezing.
But should the sample be frozen, I prefer to thaw it the day before to allow it to acquire motility sufficient to select sperm for the injection the following day.
Actually, in my experience, and of course having the patient's interest in mind, we would always do a diagnostic biopsy before the egg collection, some days or weeks or maybe a month or so before the egg collection. If there are viable sperm, we know that we can cryostore them, and then we can also make aliquots so that a single testicular biopsy, if it's a good one, will be sufficient for 2 or 3 ICSI treatments. So I would prefer to do a diagnostic beforehand and freeze the samples and thaw them on the day of the egg collection.
If it's obstructive and I'm expecting a good sample, I'm very happy for it to be done in advance and cryopreserved, and then we thaw it on the morning of the egg retrieval.
So I come into the lab, I hear alarms. I can never figure out which one it is because they all sound exactly the same to me.
Well, first of all, obviously, I want to know which alarm is going off. So do I know which one, or is everything alarming?
And it's very difficult to identify exactly where they're coming from. So just wander around, try and find out what the problem is and fix it there and then.
If everything is alarming, then obviously there's something wrong with my alarm system. Otherwise, I will identify the alarm that is sounding. If it is an incubator, immediately remove the embryos and put it in another one. If it's a tank, see what the status is. So it just depends.
So it's not a good way to start the morning.
I first want to identify what equipment is alarming. If it's critical cryopreservation or storage equipment versus a table that is overheating versus my refrigerator that is 1 degree too cold or 1 degree too warm, or my incubator that has no CO2 in it.
Certainly, if it's an incubator, that's of great concern, and you would have to immediately address that. That's the first thing you would do. And then, of course, the cryo storage.
My first thought, obviously, is the incubator.
If I'm first in and I identify it as something critical, I will see if there's something I can use to plug the hole, so to speak, as put a finger in the dike. But very shortly thereafter, mobilize my team to come assist in assessing the damage, the problem, or providing a solution with me.
If there is a malfunctioning incubator, I would have to move the embryos to another incubator, obviously. If the incubators are okay, I go to the nitrogen tanks. If they're also fine, then I take a big, deep sigh, and then I just continue troubleshooting.
But the truth is, these critical pieces of equipment are on battery and alarm and generator backup. So hopefully the first thing in the morning would not be the alarms of the incubators and the cryo tanks.
So see a dish, we think we've got contamination, get in there as quickly as possible and move the embryos, eggs, whatever, into another droplet, maybe in the same dish that is not contaminated, and then eventually onto a new dish with freshly made media that we probably don't have ready to go because it's not going to be warm. And in regards to that, I think If it's yeast, it's really not a big deal. If it's bacterial, or if it's a fungal mycelium, then it's a real challenge, particularly the mycelium, because that every now and then will just entrap whatever you're growing. Embryos, eggs just get stuck in it, and you really can't pull them out.
Well, I'm very happy to say that that has never happened before. So I don't know what kind of contamination you would talk about.
Happily, contamination in our embryo culture dishes is very, very rare in my experience.
Well, if I see a contamination in the culture droplets, which does unfortunately occur from time to time.
Quite often the contamination has originated from the patient. So in all cases, which is actually very few, I think I can count on one hand, the patient is the source of the contamination, and it's either fungal or bacterial. If it's fungal, I'm pretty comfortable rigorously washing out the gamete, the zygote, the embryo, to get it through enough drops to make sure that it's cleaned off. And bacterial is a little more tricky, but again, I would definitely rinse it off as much as possible, move it to new drops until you can make a new dish that's clean, fresh media. And then I would take the conditioned media with the contamination and send it off for culture so you know what you're dealing with.
But in our lab, that's never happened before. If I were back in my research days, I would give it a really high dose antibiotic wash. If it's a fungal contamination, I will do fungizone, and then just hope and pray for the best.
So my first approach is to do serial rinsing of the tissue that may be contaminated, oocytes typically, or zygotes, or blastocysts, embryos, whatever it may be. I then try to determine what the contamination is. I'm not a microbiologist, but I can tell if something's a coccyx, a cocci, or a rod. Is it in chains, or is it single? Is it in clumps?
You need to check the surrounding culture, see that no cross-contamination has occurred. Once you've molded the embryos to clean droplets, the samples will have to be sent to microbiology to check what's going on, if it's a bacteriological problem or what it is. The embryos may have to be cryo-stored. It's probably wise not to do an embryo transfer until you know what's going on. And of course, at the same time, the medical lead is notified, obviously, to inform of the situation, and the patient has to be informed as well.
And I also, in my lab, I save the semen, the washed semen, until I throw my last embryo away. Because I can tell you, in my experience, 9 times out of 10, the contamination comes from the semen, either the collection, the processing, or the individual.
Well, that was great. We are ready to take questions about any subject. We'd really like to start and talk about Graham's topic, low sperm counts. And I'll just start to say, Graham, you mentioned that if you don't have motility, one of the things you do is that you look to see indications of sperm being viable. Could you expand on that a little bit? What are you looking for?
Well, really just sort of poking them around with the ICSI needle. I mean, I'm happiest to have sperm where the tail is kind of flexible. If they're like a stick and just don't move, I'll be less inclined to use them. I also prefer to have any sperm that maybe have like a remnants of a cytoplasmic droplet or something like that around the neck. I just have a feeling that maybe they're more recently produced, more recently made, rather than older sperm that have been maybe hanging around a little bit longer.
Yeah.
Can I ask a short question, Graham?
Yeah, try me.
I noticed that you had a low G number on your centrifugation. Is there a reason for that? You showed a mini gradient, I think.
Yeah, 150 G.
Yeah.
Or like 20 minutes. I mean, I think that seems.
Why
to
not
work
300 or 500? You usually do that for sperm prep?
No, we use that 150 G for pretty much everything with our sperm. The sperm seem to come through, and that's kind of the lowest, I guess, the lowest level that we're comfortable with, where sperm will make it through the gradient, or we'll sediment out in a in a spin down for a wash. I mean, always trying to go, I guess, for the absolute lowest speed possible.
Right.
Graham, this is Sangita. I think I do almost exactly what you do, but we also use something called a tissue grinder. Have you heard of that?
I have, and I've used those. And I
don't love them.
I've stopped. Yeah, they were great. I really had a good time with them. But I think you can do just as well with needles in a dish. The grinder makes like a, I don't know, almost like a gel.
A paste.
A lot of protein.
Yeah.
And everything just gets stuck together.
Yep.
I just think just dissecting works better.
I was interested that you used a hatching needle to pick up the sperm and move it to because that's exactly what I do because of the debris.
Yep.
That was a good tip. I hadn't thought of that myself.
One question for you, Dr. Brown. Hello?
Hey.
I want to ask you about severe cases that have very low mortality with bad morphology. If we have one motile sperm with bad morphology and another immotile sperm with somehow good morphology, which one is preferable to choose?
Yeah, I really don't know. I would go with the one, if there is one that has a head volume that is kind of normal, I would go with that one. I mean, if you've got a motile sperm with a grossly abnormal head, particularly, then as opposed to one with a normal-ish looking head, a normal volume looking head, but is non-motile, I'd go with the more normal looking head.
Okay.
Do you, and this is for Graham or anyone actually on the panel, have you used enzymatic digestion in testicular preps like collagenase?
I mean, we have tried it a little bit, and I think much like the tissue grinders, you end up with this sort of gel stuff that sperm really don't want to come out of.
Yeah.
We actually use that routinely for if it's a very low number of sperm that we get from the tissue. We use that and it works pretty well. You can prevent it from getting sticky by adding the RNAs. Also, you can do a discontinuous gradient centrifugation afterwards to separate the somatic cells from the blood cells from the, I think I did it in your lab once or twice, Graham, when I was there. Discontinuous gradient. So we actually, for us, the enzymatic digestion actually works very well. Also, we sometimes go off-site and do testicular tissue harvest with urologists. That's about an hour or 2 hours away, and then we have to freeze it. Even if we don't see sperm, we freeze it, and then the patient will drive it back to our lab, and then we will thaw it and do enzymatic digestion. And we feel like that's really the one where you can say unequivocally, you've done everything you can. You know, there's no sperm that's hiding in tubules or anything because you've dissociated all the cells. So we actually really do use that routinely.
Dr. Brown, in testicular samples with very few number of sperm or maybe severe cases, you used how you use the zonas for sperm or sperm vitrification devices to freeze the sperm?
No, we try and avoid freezing testicular sperm. If we do freeze it, we'll freeze the whole tissue, everything that we get after dissecting. So we'll freeze everything. We don't try and get the sperm out of it until after we thaw it.
When you go to select sperm for ICSI, Graham, is there any morphological abnormality that you will not use for ICSI?
I mean, if it won't fit up the needle, there are days like that. Like I said before, I think if the head volume looks relatively normal, it doesn't have to be the perfect shape. Then I'm okay with that. It's one of these things where some days, you're never going to find a normal looking sperm.
Yeah.
So, that's my best kind of guess for normality. Maybe genetically.
Can I ask something? What about different types of biopsies? From the look of it, you're getting very, very good material. This is an open biopsy, I think, just old-fashioned. What about microdissection testicular biopsies? Do you do those?
Yeah, we do those as well. I haven't got any video of any of that kind of stuff.
No, but that would probably be the same.
The percutaneous biopsies as well for people who are, say vasectomies or something like that. But a lot of our samples, even where we've got an obstructive issue, we don't get great sperm. Some we do, but there are a lot where we just don't. And our urologist seems to know what he's doing. He seems to know what is the best way of giving us tissue. He will kind of go towards, I guess, the bigger chunks, right, if he believes that's the way to go.
Well, the key is, of course, to have a good colleague or a doctor who is routinized and is doing this all the time, as opposed to someone who's just doing it irregularly.
He is good. Mike Witt, our urologist, is very, very good.
Yeah.
Do you test for? Do you make testing for the frozen sample before sawing to assure the remaining samples will be okay after sawing, or no?
The only time we really ever freeze testicular samples is kind of last resort kind of stuff. So no, we don't thaw them and check and see what we're going to be getting. I mean, we're really trying to avoid freezing testicular samples at all.
Yeah. Let me ask you just one more question before we move on to Barry's topic, and that is, you mentioned you use the Zymo chamber for sperm concentrations greater than 1 million. Did you determine that experimentally, or is that just a cutoff you did sort of empirically?
It's a cutoff that we, I guess, came up with. And those chambers, they're nice. I mean, they seem to work quite well. They're quite expensive, but takes an awful lot less sort of human input. Yeah. And we did find in just trying them out, in a few cases, that we got more normal embryos for aneuploidy screening from the Zymo samples, which is what they claim, but
interesting.
You never know.
Yeah. Well, thank you very much. Appreciate it. So Barry.
The next topic, Dr. Barry. Hello.
Hello. Yes, I'm here. Hello, everyone.
How do you check the validity and safety of new equipment that's implemented to the lab?
Well, it depends what the piece of equipment is. If you're talking about a new liquid nitrogen tank, it's a different sort of validation process one would go through versus an incubation chamber. But the bottom line is, any new piece of equipment you want to validate. You want to make sure it's working to the expectation that you had before you bought it or when you bought it. So if it's a liquid nitrogen tank, you want to make sure that it can maintain the temperature or the level of liquid nitrogen or the conditions, whatever you're monitoring, that you basically paid for, you expected, and test that over a period of time. It could be a few weeks, it could be, minimum, I would say, which is what we do here, or it could be longer. It just depends on your need and, how soon, and how much space how soon you need it and how much space. So the bottom line is validation. You want to make sure you validate the equipment. If it is an incubation chamber, a new incubator, for example, which is probably the most sensitive piece of equipment we have in our armamentarium, we want to make sure that the conditions are not going to cause any harm to the embryo, and that relates to off-gassing. There's from A to Z on what people do on off-gassing, and what I found is it's very much brand specific. So some brands seem like they need, and I use the word seem importantly, critically here, because I don't have, VOC values to tell you before and after or other measurements, but some equipment seems to be more embryo friendly sooner than later. So again, it depends on the brand, but we would first make sure the conditions are not toxic, then and validate it to ensure that it's maintaining the parameters that we set, and then use some surrogate embryos like mouse embryos, one-cell mouse embryos as just a culture box to check to ensure that they will grow comparably to blastocyst as a control. We always want to have a control, an existing piece of equipment that you can, use as a yardstick to compare to. And assuming those pass, the last step I do is do a sibling oocyte culture. And I don't do necessarily statistics. This is the art of ART here, where the lab director has a feel and looks at this, been doing this for a while. The embryos look the same, the FERT rate's the same, the quality's the same, we're good to go after all those preceding steps have been done. So those are two examples.
Can I ask a question, Barry?
Of course.
Thanks for a good presentation. That was excellent. I thought that your comment about how we cannot expect things to improve without changing something was very valid. I mean, I'm sure we've all seen IVF labs where people are just afraid to change things. I think it's because they don't really know what they're doing, but that's another story. There's something that I've noticed from time to time, and especially with micromanipulators and the more sensitive instruments, there is a degradation of equipment over time, and people who are working with the same equipment from every day, they don't notice. And I think that's a big reason to change and upgrade, because and then suddenly your results will jump if you change. So there are all sorts of initiatives or incitements or reasons to change, aren't there? Wouldn't you say that?
Yeah, no, certainly. And I think I put 6 up there that I could just think of in preparation for this. But yeah, there are many reasons. And, again, you can argue that, and this is the one example I was using, I had microscopes that had a 6x or 8x magnification from the 90s or the 2000s. And now I've got 16x, so I can see my PNs better, but I confirm it on the inverted scope anyway. So having a better dissecting scope is not going to change my pregnancy rate. It may be nicer to see more, and you can see, but arguably, PNs are big structures. You can see them on an 8x, and you're going to confirm it on a bigger scope. So yes, I agree. Some equipment may degrade over time, but our jobs as embryologists and lab directors are to ensure that we have, quality assurance and maintaining the performance. And if the key performance indicators deviate, then you need to start looking at, is equipment or is it technique drift? Is it equipment drift or what have you? So, I don't disagree with you, but I think we should have systems in place to try to sort of keep the bookends on that so things don't completely derail because our manipulator's leaking oil or getting air, and we're blowing up eggs and we didn't notice that, type of thing.
For sure. I have another one just since we're talking.
Sure.
There's just something I noticed that I'd just like to bring, what I thought was interesting. Lovely new laboratory you have, of course. And I noticed one thing, apart from the lovely equipment, there was no paper anywhere.
Yeah.
I think you were standing there with a piece of paper in your hand, but that was basically the only paper visible in the lab.
Well, yeah, a good observation. We do use worksheets. So, we have a lab EMR, electronic medical record system, that connects to the hospital big electronic medical system that we're in. So yes, everything we communicate, even with patients, via MyChart and apps, electronic communication, which many people argue is impersonal, but it's very efficient and it's the wave of the future, unfortunately. It's a way to get information out, efficiently and immediately. But I still rely on some paper, Julius. When we're doing ID, we're comparing things from a piece of paper. The chain of custody is still a hand signature from the patients, from the male partner or whomever. So yeah, I don't have, my binders all out of the lab. Try to minimize it, but it's not zero at all. It makes dust. That's, the worst thing is it makes dust, but it gives you a crutch. And I still, maybe I'm old, but and my staff still like it.
Barry, when you go to purchase new equipment, let's say incubators, there's a wide variety to select from. So what advice would you give the more junior embryologist if he or she were charged with picking new equipment for a lab? How do you go about selecting between a single item?
Yeah, well, I mean, that's a great question, Rusty. Very, very insightful and important as well. I guess the first question is, sort of the low-hanging fruit and this is literally going back to the beginning, are you looking at, a tri-gas incubator, or are you looking at a CO2 basic incubator that you get in a research lab? So type of gas mix. Secondly, are you looking at, pre-mixed or not pre-mixed? Does it achieve that tri-gas on its own, or do you have to supply it? Probably first and foremost is, do you want humidification or not? That's a big debatable item. And I noticed, Graham and Peter, in your lab, that you guys use a dry incubator, at least some of the bench tops. I have the same ones, and they work fine. But it was a big mental leap for me after reading some of the literature out there about dry versus humidified incubation and the impacts even with oil. It made me concerned. So, recognizing, are you going to be culturing in, micro drops with minimal oil? You're risky in a dry incubator. If you're going to culture in large drops with big oil overlay, maybe you're fine. So those are sort of the big ticket items. And then it comes to, space, footprint. Does this piece of equipment fit where I want it to fit? And then last but not least, brand. The brands, they're not insignificant. They have different gas pressure requirements, some of them power requirements, and others off-gassing requirements. So I would, talk to your friends and our colleagues in this rich community we have, and, with no conflict of interest, try to find out, look, I used this 2 weeks after I bought it because our incubator crashed and we're busy practice, so we didn't have time to off-gas it for 3 months. And, we were fine, and you talk to someone else who did the same thing. It's like, well, maybe I don't need to off-gas this for 3 months or cook it for 2 weeks. So those are the maybe make a long answer to a short question, Rusty, but that's kind of the off from the cuff advice I can think of right now.
Yeah, those are good. The only other thing I would throw in, Barry, is service.
Oh yeah, absolutely.
I mean,
yes,
that's huge.
Huge, absolutely. Probably, first or second on the list. If you can't get support, don't consider it, even if it's the best piece of equipment that everyone recommends. Yeah, thank you for including that. Absolutely important.
Yeah,
critical.
Very good.
Critical.
I want to ask our speakers another question about the incubators that have a life of 5 to 8 years. Should you use a piece of equipment that is no longer in warranty?
Yeah, I mean, I would say yes. I think if equipment is maintained and monitored, warranty is to give, I think, the purchaser, I think there's a difference between a warranty and lifespan of a piece of equipment. So warranty is to give the purchaser some insurance that should something break within a certain period of time when the instrument is still new-ish, that the manufacturer will sort of have some skin in the game and give you some credit or repair it for free or what have you. I think, like a car, for example, I don't think a car is not good anymore after warranty if you maintain it properly. I like cars, so that's an easy analogy for me. So the short answer is, yes, you can use equipment out of warranty. The one thing that comes up and is contentious are liquid nitrogen tanks, not incubators, because people worry, are they vulnerable if the tank is not warranted? Does it mean it's no longer in the usable life? And my argument would be no. I mean, this is a lawyer question, not a science question or a physics question. But I believe that you can use equipment outside of warranty. And also balancing, Julius's point about, once you get out, 20 years outside of the warranty, maybe there's some other things to consider.
Yeah, very good. Well, I think we probably need to move on. We're getting on in time a little bit. Thank you very much, Barry.
Of course.
So, questions from Sangita's presentation. It was really an excellent, nice, concise, but information-packed one. Let me just start by asking you, do you put your patients on prophylactic antibiotic before an ART cycle?
I'm afraid we do. We're old school. They do. Yeah.
And what do you use?
Oh, I don't know at the top of my head. It's Doxy.
Yeah.
Now, having said that, we do have some patients who come in for FET monitoring. They just don't mount a good response. We find out they have endometritis. I think there was a recent paper saying there's no impact of endometritis, but when we give them antibiotics for that, we definitely see an improvement, and they implant after they've been treated. So it's case by case, but also we do general, yeah, broad spectrum.
Dr. Sangita, I want to know your tips for troubleshooting the source of contamination if you find a contaminated culture dish.
So I feel a little, how do I say, self-conscious answering this because I've seen it like 3 times in 25 years. So I don't really know if the right answer is what I'm telling you, but I can tell you what I have done the few times. And it's exactly what everybody else said when they were asked that question on the video. You first of all, your heart sinks. You just take a look at it and you try and figure out if it's fluffy and just like clusters of grapes or whether it's rods and what it is. And then you look for a clean droplet in the same dish that you can then extract, say the blast on day 5, that's usually when we check them, and move them through the other drops and really rigorously wash them. And if they have to prolong culture, you have to make a new dish, which takes a while. I also check that the other dishes in that incubator, if there are any, we try not to share too many, are clean. And as I said, I think in the video, it's almost always from the patient. So it's patient specific. So we just don't see general contamination, thankfully, knock on wood. So the other part of that question is I would consider transferring if they have nothing else. If you are able to wash it, depending on what it is, I suppose, if it's bacterial, it's a little more complicated, and there's some data showing that they don't do as well. But the fungal ones, the yeast ones, if you can wash it, and you have no choice, I would transfer.
I have a question, Sangita. So let's say it's day 5, you're doing a freeze all. Would you wash it and then freeze it immediately, or would you try to get rid of the contamination first?
Well, I think washing is the only thing I can think of to get rid of it. What would you do?
I mean, instead of like washing and then immediately freezing, would you wash it and then culture it for a few hours to see, or maybe until the next day to see if you got rid of the contamination, or would you just wash it as good you can and then immediately freeze it?
So again, this is hypothetical because I've never had to do it, but I guess I would freeze it. I don't know. I would freeze it.
Anybody else?
I just follow up on that with a comment, because there are a number of studies showing that a surprisingly high proportion of the sperm samples that we get into the lab has bacterial contamination. I mean, up to 60% in some studies. So it's a huge proportion, actually. I would say it's probably amazing that we don't see more contamination than we actually do. Obviously, with ICSI, it's less of a problem. But Sangita, can I just ask you, given that you may have some embryos not eligible for transfer, but freezable, would you use like a high security device for vitrification, or do you do that already for vitrification of embryos?
So this is a bit of a vexed question. So we don't really get contaminated samples to deal with. What I would talk about, though, is virus positive samples. So yes, so if I have embryos from a couple where usually it's the male partner, I'm not going to lie, who is virus positive, and I've made these embryos, we do actually have a protocol to cryopreserve, vitrify them in HSV, which is the cryobiology, which is the one that's FDA approved, I guess, is closed. And so we really don't use that very often. We used to, we don't anymore. We use an open system, and it's the one that everybody else is using, I'm sure. But for those patients, we do have that protocol. And so that is also to protect the other patients in the tank. We don't have separate tanks. And so if it's a closed system within the tank, we're very comfortable. And, being in New York, being in the Bronx, we've had patients who are virus positive over the years, and we've always treated them. We are not one of those programs who says, no, we don't do them, because we can take precautions and make accommodations. And I would encourage people to open that door for your patients. I think it's a very doable thing to treat these patients.
Yeah, I completely agree. And I have to say, in this part of the world where I'm from, in Scandinavia, sitting at the moment, I mean, there are labs who would not consider cryopreserving embryos at all from patients. They may treat them and do a fresh transfer, but no embryo cryopreservation. And that's a shame, because, as you say, there are safe ways of doing it. This is what people need to hear.
No, I mean, I just wanted to answer Liesel as well. I mean, unlike Sangita, we do see a contamination probably once or twice a year out of 1,500 cycles. And I've seen this. It's not something I've never dealt with, unfortunately. And 90+% of the time it's from the semen, which is why we developed this protocol to basically keep the tube at room temperature in a cup. And it saved me 99% of the time. It saved me. I go back and culture that, send the same culture as my culture media, and it's the same thing. Now, and it's either a skin contaminant or a fecal contaminant. Unfortunately, E. coli, which is devastating to the tissue culture, and it's mostly in men who are uncircumcised, unfortunately, it's something that we've seen, and we've even cultured men to basically make this connection before that. And also the type of, we always get it cultured, as I think Julius mentioned, and get it sourced, as we aren't microbiologists. And the type of fungus or bacteria can tell you where it came from. You know, so that if it's a skin or it's an environmental and air, you know, one time I can remember ever from 15 years ago, we had a aspergillus in the thing, and that's an air, that's from the air that and it was not in my fancy air lab. And that's one example of where a new system, a proper system could have saved us. So, you know, it does happen. And, you know, any sort of back tracing you can do can help you just reassure that it's not a technical or technique thing that you want to rule out immediately.
Do any of you have some antibiotics in stock where, because obviously most of our culture media does have, I think most of them have gentamicin these days, right? Where, because if an embryo has made it to day 5 and you have that contaminant, you would think it's probably resistant to whatever by antibiotics is already in the media. So would you add something different like pain strep to when you do this high antibiotic wash, or culture it maybe for a few hours in this high antibiotic of a different type, so that if it's a resistant strain of bacteria, you hit it with something else?
Yeah, we do. But I would say that if you have something that's resistant to gentamicin, it likely isn't going to be effective using pin strep. You'd have to use some other a little more exotic, you know, antibiotic. But I would, you know, come back to one point Barry made, and that is a very effective tool is serial dilution. And I mean, and you can't go to too many drops. I mean, you can do 10 dilutions and do pretty well with that. You can also do a very mild proteolysis. You can do a very quick, but very mild proteolysis, and that doesn't seem to do you. If you're not removing the zona, you're okay, and that doesn't really damage too much. But it's you know, the technical problem with that, Graham pointed out, and that is you usually don't have a equilibrated warm medium to do something with. So one trick is just to simply always have on hand the availability of some organically buffered solution, you know, either heaps, mops, or double buffered solution. You can warm that quickly and hold embryos in that for a really extended period of time before you can get maybe culture medium warmed up. You probably won't be able to get it gassed to the appropriate level, but you can get it pretty close, I think, by doing that. So serial dilution is a good method along with mild proteolysis.
Sterilization by dilution, Rusty.
Yep, there you go. I have one more question for you, Sangita, and that is,
yeah.
Do you do anything special with frozen embryos from COVID patients?
No, we don't.
Okay.
The women are negative, and we don't test the sperm, and I realize that's a little controversial, but we just don't. And we don't. We freeze them. I will say we don't cryopreserve semen unless they've been tested. That is the only thing I will say. But the sperm, the embryos, we are freezing. I don't know. I've seen papers where, you know, not the viral particle. Yeah, the virus is actually present in fluid and in, I don't know if it's in embryos. I'm just not sure. So if those studies have shown that, but I don't segregate them and I don't not freeze.
Okay. Great.
I think we should now turn to the first topic. Dr. Liesel, I want to ask you a question about hatching. Which day will be better to hatch the embryos? Is it day 2, 3, or early blast stage?
I honestly don't really think it matters. I think it's whatever works the best for your lab's workflow. Like Graham has pointed out, if you do it before you have blastulation, you may hatch it on a side where the ICM may then hatch out. And in those cases, you have to go in from the other side of the embryo because you want to, cut off the ICM. Like Dr. Burr said, he does it basically at the 2pn check. I don't think, but that's just my opinion, that physiologically it makes a difference when you do it. Personally, I like to do it on day 4. Like I said, I know usually you can already see where the blastocele is forming, so you know where the ICM is going to be. But I'm also totally comfortable not hatching in advance at all. Sometimes the morning of, we see there's some that we didn't think was going to make a blastocyst and didn't hatch it the day before. I'm comfortable biopsying it without pre-hatching as well. So I really think it just depends on what everyone is comfortable with and what works with your lab workflow. Some people don't check on day 3 anymore. I think a majority of the people don't check on day 3 anymore. So for us to pull embryos out just to do a hatch on day 3, if we can do it later, closer to blastulation, I think it makes sense. But if we don't have anything to do in the lab on a weekend that day, we may do it on day 3. So it really just depends. Anyone else want to comment on that?
Okay, I have one more question. During the MP biopsy, what's a good number to take from the MP? And how do you determine the number of cells you are removing?
The number of cells that you biopsy?
Yes.
Every time I fill out that form from the genetics lab, I smile because I know that no one has a clue how many cells they're putting in that tube. It's purely, you just don't. I mean, you can kind of count it while it's expanded, and as soon as you start biopsying it, it collapses. Anyone that can really count the number of nuclei that go in there, very good for you. But I don't. I estimate it's around 5 cells. That's my comfortable level. I feel like if you go below that, you're more likely to get no results. And if you go more than that, I think it's redundant. You take more volume of the embryo. But then people may say, well, what about mosaicis? And the more cells you take, the bigger the chances you might get, if there is mosaicis, and you get one of those cells. So my answer is I try to go for around 5, but when I fill in the form, I make a squiggly in front of it because I know for a fact that no one can tell how many cells there really is on that biopsy.
Thank you for your painful honesty. I agree with you completely. That it is a joke.
Really?
That's very good. Lisa, do you ever centrifuge samples after you've loaded the tubes?
This is another complicated thing, is every company has different instructions.
Sure.
Right? Some of them say you have to do it. Some of them don't require it unless you know the drop is not in the bottom. We don't routinely unless, like I said, we feel like maybe the drop with the biopsy is not in the bottom, but we don't routinely. Yeah. Our company doesn't require it either.
Right.
Okay, the use of laser generates heat energy, which negatively affect the embryos. If there is anything you do to try to reduce that effect?
From the laser?
Yes.
No, I mean, we obviously, whenever we align the laser or do anything, we will not have embryos near it in the dish or anything. Like, when you align it, you don't want embryos near it. We try to biopsy it as far away from the ICM as possible. That's not always possible. And try to minimize the amount of pulses we use. Sometimes just by experience, what is going to work better. Some embryos, it's easier to just do a smaller diameter cut and it will come loose. Some of them, it's going to work better if you have a larger diameter for the laser pulse, but you can do fewer pulses. So it just really depends on the quality of the embryo and how it behaves. It's amazing how different embryos can behave differently. Some of them will make like a jerky. I'm sure you all have seen that. You try to cut it and it just would not let go. But I'm always conscious that this is a laser that could potentially be harmful to the embryo, and you try to keep it away from the ICM as much as you can. If I can just add one more thing about the loading part that I forgot to mention, I definitely try to, if the company that you use send you the labels, I put the label on after I load the biopsy. I would label it in the on the top, because I never want to lose sight of the tip of my needle that the biopsy is in. So I have the opening of my tube, I have the needle, and I can see the whole way. If you have a label on there, you lose sight of it even for just a short amount of time, but I feel like you're more likely to accidentally touch it if you do that. So that's just one thing that I wanted to comment on as well.
Okay. Thank you, everybody, for taking time to participate in this session and this discussion. I particularly like to thank the I3 speakers, Dr. Graham, Barry, Sangita Liesel, and co-host Dr. Rusty Poole, and the expert, Dr. J. Herndon. Thank you to the organizing committee of this initiative, Dr. Jax Cohen, Peter Nash, Thomas Elliott, Shiasta Sadruddin, Jilis Palmer, Mary Ann Savitas, and today's Q&A team were Mary Ann Savitas and Aina McLaughlin. Thank you.
And thank you everyone for your participation and a great question and answer session. Just as a reminder, the session will be on the website, on the I3 website, usually within about 48 hours. So please check that if you want to follow up. And again, you can learn more about panelists and speakers if you want to check the bios that are on the website as well. As a reminder, next week is the next session, next Tuesday. Also, I want to point out that in some regions of the world, such as the US, we'll be changing time. We'll be going to a different time, an hour difference. So please be careful that it's still going to be from US time, 3 Eastern time, but it may be an hour difference, an hour shorter, depending on where you are in the world. Next week, it's going to be a great session. The session is going to be on theorygenology. We're going to have 2 phenomenal moderators. We have the editor of Theorygenology, that's Professor Fulvio Gandolfi, very, very well known. And he's going to be joined by Dr. Denny Sakas from Boston IVF. And they really have a great lineup of speakers. So we encourage each of you to check your emails, get registered, and we'll see you next week for that really good session. And again, thank you everybody for your participation, and we hope you'll stay tuned to these sessions. They're fantastic. Thanks all the organizers of the I3 for doing that. So with that, we'll just tell you goodbye then. Thank you.